Okay, we have here today a pretty complicated looking integral from the UNSW Integration Bee. This one here is from 2023, round 2, problem 13. We have the integral of 1 plus e to the 2x times 1 minus 2x over e to the 4th x plus 2 e to the 2x plus 1 dx. Okay, my first thought here was I need some way to maybe simplify this with some algebra, just because I'm not seeing an obvious u substitution that would work. And just notice that if we look here at this denominator, this actually is a perfect square. So what I can do to rewrite this, just focusing on the denominator, I can actually write this as e to the 2x plus 1 all squared. And then for the numerator, I think what I'm going to do is actually distribute this in. We could leave it, but let's just try to distribute it. So this is going to give me 1 plus e to the 2x, and then multiplying with this term, we're going to have a minus 2x e to the 2x. And now at this point, it's still not looking that great. I don't really see a good u substitution, but what I do notice is that we've got a squared term in the denominator, and we've got some similar looking stuff up here in the numerator. It makes me think this might actually be the quotient rule. Okay, so we have our quotient rule over here to the right, and just notice it's kind of similar, right? We've got if we think of this right here as our g, then we have our g squared here. And then hopefully in theory, this chunk here would be f prime g, and this chunk right here would be our fg prime. It kind of makes sense because we have exponential, we have a e function in both these. And also notice we have this minus sign, so this looks kind of promising. And so the way this would work is we want this function here to be exactly this, and then if you just take a integral on both sides, and then on the left side here, because we're taking the integral of a derivative, this thing is going to be just f over g. So if this is all in the right form, and we can find our f and g, then we have our solution right here as f over g. So the good thing about this is we know what our g needs to be. So we'll start with g, because we already have that. So we'll say g is e to the 2x plus 1, and then let's find our derivative. Let's get our g prime value. So g prime is just going to be 2 e to the 2x. Then from here, we want to find an f value. We already have our g and g prime. What I want to do is match, again, this fg prime to this piece right here. We're saying fg prime needs to be 2x e to the 2x. Now we already have our g prime here as 2 e to the 2x, so if we made our f equal to x, just notice multiplying x times 2 to the 2x, that would give us this. So if f is going to be equal to x, then we could just take the derivative of this and find our f prime, so we're saying f prime is going to be just 1. So now at this point, the only thing we need in order to make this work is we want to check our f prime g value, and we want that to be exactly this. So we have our g and f prime right here. F prime is just 1. So let's see, our f prime g, 1 times this is going to be just e to the 2x plus 1, but that's exactly that. So it turns out that we have this thing exactly in this form with our g squared in the denominator, f prime g minus fg prime. So our solution is just going to be f over g. We have both those values, so our f over g is going to be just this x, and then our g value in the denominator is going to be e to the 2x plus 1. Just going to add a plus c on there, and that's it. And if you wanted to double check it just to feel good about it, you could just take the derivative of this thing using, again, the quotient rules. So the derivative is going to be just f prime, which is going to be 1 times this thing, which is e to the 2x plus 1, and then minus our f value, which is x, times the derivative of this is going to be 2 e to the 2x. And then it's just going to be over this thing squared, e to the 2x plus 1 squared. And then again, you'll notice that this piece is just this, and then if you distribute in this x, you have this piece here exactly, so it all works. Okay, good problem. I like when we can use the quotient rule in reverse on an integral. Let me know if you had a different way to do this. I'd be curious, and let me know how it compared to this method as far as speed or whatever. Anyway, we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.